Are you responsible for your databases on AWS? Do you need to meet strict RPO and RTO objectives? Are you finding it expensive and challenging to achieve your desired SLAs? If so, we have great news for you. There's a way to meet your SLAs no matter how aggressive they are, and even reduce cost in the process with FSx for ONTAP as your underlying storage. Benefit from high availability across availability zones, efficient DR, optimized compute usage, and minimized data cost, as well as efficient snapshots for faster backup and restore. In this FSx for ONTAP workloads inside and out video, we'll show a real customer case with relevant architectures, explain the technical capabilities, and present a hands-on demo. Let's get started. So, you're running your databases on AWS and need to meet stringent resilience requirements like this financial services company that was running its self-managed SQL server as part of its SaaS platform on AWS. They had hundreds of databases with over 500 terabytes of capacity and numerous environments for dev test, pre-prod, and other purposes. Because the platform was mission critical, the company had demanding resiliency SLAs. They needed high availability, an RPO of 10 minutes and RTO of 1 hour, and to ensure business continuity, they needed an effective disaster recovery site as part of the architecture. To meet the high availability requirement, the company had a SQL always-on availability group architecture with an enterprise license, but they still struggled to meet the required RPO and RTO and couldn't build an efficient DR site. This was resolved by adopting FSx for ONTAP as the data storage layer and offloading the replication tasks to it. This resulted in meeting the RPO and RTO requirement, getting high availability across availability zones, getting backup tasks done in seconds and restores in minutes, building an efficient DR site, and the cherry on top was that all of this was accomplished using an SQL FCI architecture, resulting in a 40% reduction in licensing and maintenance cost, as well as additional savings on compute and storage. Ultimately, the company not only elevated its availability, resiliency, and data protection, but also optimized cost while doing so. Want to understand how FSx for ONTAP did all this and what it can do for you? Let's take a closer look and see a demo. Amazon FSx for NetApp ONTAP is an AWS fully managed storage service powered by NetApp technology. It provides intelligent storage for business-critical workloads through a comprehensive and flexible set of storage features for accessibility, resilience and protection, data security, price performance, and data mobility and copies. Let's see how FSx for ONTAP provides optimal cost and performance for Microsoft SQL database protection when it is used as the underlying storage infrastructure. This is the common architecture. 2 SQL Server nodes are deployed on 2 EC2 instances, one in each availability zone. Each EC2 is attached to an EBS disk, providing persistent block storage. To keep the synchronous replication between the SQL nodes, SQL native replication is used. This is an always-on availability group architecture that requires a SQL enterprise license, which is expensive compared to the standard one. It also uses 2 copies of the data, the same data on each Amazon EBS device, and compute resources are used to replicate the data by the SQL server. For database-aware backup, EBS snapshots are used, that are then archived in Amazon Simple Storage Service for high durability. Even though EBS snapshots are incremental, they are not database aware, so using SQL DAP is necessary. The implication of this backup method is the creation of a full data copy for each backup, resulting in a lengthy backup process and additional storage costs. On top of that, building a DR site is a real challenge using this architecture. Now, let's look at an architecture using FSx for ONTAP as the underlying storage. Because FSx for ONTAP provides high availability across availability zones, it can be utilized as a shared block storage for both EC2 instances. This allows moving away from an always-on availability group architecture to a failover cluster instances one, while getting the same or even better availability. For this architecture, a standard SQL license can be used, substantially reducing licensing costs. Additionally, this architecture reduces storage capacity and costs by eliminating cross-availability zone charges. And without the need for SQL level replication, EC2 instances sources are freed. For backup, FSx4ONTAP's efficient snapshots are used, which are created instantaneously, do not affect the performance and consume minimal capacity. Thanks to an integrated free tool called SnapCenter that synchronizes this snapshot with the SQL server, they become database aware and require no log forward activities as part of the restoration process. A second layer of protection against physical failure is achieved by deploying an additional FSx4ONTAP file system and replicating the snapshots to it. The replication is done with the FSx4ONTAP's built-in replication engine called SnapMirror. The additional FSx4ONTAP file system can be deployed in the same region or in a different region with a different AWS account, and is therefore considered air-gapped. Because the snapshots are incremental and highly efficient, the backup is rapid, and the restore is essentially as quick as creating a new FSx4ONTAP file system. The snapshots consume minimal capacity and add minimal costs for each backup. By deploying an additional SQL server in another region with FSx4ONTAP, you can also get an efficient DR site. Thanks to the built-in cross-region replication engine, this is still achieved with the same FCI architecture. On top of all this, because the replication is done on the storage level, the EC2 instances are mostly idle, used only in case of a disaster, and therefore save on compute costs. Now that we understood how FSx4ONTAP can help you optimize your SQL protection, let's look at a few demos of what we discussed. FSx4ONTAP provides optimal cost and performance for Microsoft SQL database protection when it is used as the data storage infrastructure. In this demo, we'll showcase how to create and restore database-aware backups with SnapCenter, a free tool for FSx4ONTAP customers that assists in orchestrating data protection aspects. Assuming we already installed SnapCenter in our VPC and configured it with our SQL server, let's see how we can use it to run a backup process. We have a SQL instance on which we host the production data. We have two databases, one called TPC C1000, which has 147 gigabytes of data, and another called TPC C30000, which contains 3.1 terabytes of data. This is SnapCenter's resource view, where we can see the list of protected databases, including the two databases I mentioned. Here we see the pre-configured backup. There is one full backup alongside system backups running daily, and these system backups running hourly. Now let's take an ad hoc backup of the 147 gigabytes database. The service asks us to confirm taking an ad hoc backup, even though we already have a scheduled backup as part of the policy. If we look at the activity log, we can see that this backup task ended 9 seconds after it started. It took only 9 seconds to backup 147 gigabytes. Now let's run the same tasks on the 3.1 terabytes database. What we can see is that this backup task took 9 seconds as well. Only 9 seconds for a 3.1 terabytes backup. This showcases the snapshot technology efficiency and the advantage it provides for backup operations. Now that we have point-in-time backups, let's make a change to the 3.1 terabyte database. We'll first run the database and see it has no table, and the same is true for the backup. Now we add a table to the database, run it again, and see the new records. Let's run another backup that includes the changes we just made. Let's see how long this process took. We see it took 12 seconds. Now we have backups for before and after our change. Let's see how long it takes to restore the 3.1 terabytes database. I'll walk us through the restore wizard. I can choose the location of the restoration. In this case, I'll restore to the same host where the backup was created. For the sake of the demo, I'll not use the T-logs, but they are also supported. I'm going to override the database with the same name during the restore and remove the table we've just created. Now I can select if I would like to apply additional transactional logs as well. I select the operational option, which includes the transactional logs, which makes the restored database immediately usable. I can decide whether I want to be notified over email about this task. And then I have a summary view to confirm the operation. We can see that the task ended 8 minutes after it started for a full restore of 3.1 TB of SQL data. Yes, only 8 minutes. Now let's refresh the database. Remember that the backup we made is based on a database-aware snapshot, so there is no need for log shipping. You can see that the table is no longer there, meaning we restored the data to its state before the changes were made. FS6 for ONTAP elevates your database resiliency on AWS. Its unique capabilities provide high availability block storage across availability zones, highly efficient database-aware snapshots, and built-in cross-regional replication technology to help meet even the most demanding RPO and RTO targets. This is why so many companies have chosen FS6 for ONTAP as the underlying storage for their databases. With FS6 for ONTAP, you can take your database workloads to the next level of performance, resiliency, and cost optimization. Don't forget to check out our other FS6 for ONTAP inside and out videos to explore more benefits and features of FS6 for ONTAP.